Hello friends, welcome to our channel Knowledge Amplifier. So in my previous video I have shown you how we can use decision tree for regression problem, right? The MATLAB implementation I have shown you using fit R tree. Okay, now let's try to understand the mathematical intuition of the actual algorithm which works behind the creation of the regression tree. Okay, so for this particular discussion purpose I have taken one small data set. Suppose we are having three columns. First one is basically our output, which is we have to predict. Okay, and this is nothing but student's final score. Okay, final exam score. This second column is hour, that is total number of hours the student has studied. Okay, and this one, the last column, is basically midterm score. Okay, now suppose you have used the dataset to create decision tree regression model in MATLAB using feature tree, and after creating the model you have seen the tree, and after applying view you are getting suppose this kind of tree. So how our model is going to predict the final exam score based on total number of hours studied and midterm score? See, very simple. First it will ask this question: if total number of hours studied is lesser than 10 or greater than 10. If it is lesser than 10, it will directly conclude that the student's final exam marks is going to be 39. But if it is greater than 10, it will ask one more question: if the student's midterm marks is greater than 65 or less than 65. If it is less than 65, that time the machine learning model will predict the student's final exam marks as 70, and if it is greater than 65, that time our machine learning model is going to predict the student's final exam marks as 82. Now you might think, how the algorithm is deciding which, based on which parameter the splitting has to be done first? Like here, why we are choosing hours instead of why we are not choosing midterm here? And one more question: if we are choosing hours, okay, why 10? It can be 12, it can be 13, it can be anything, but how our model is so specific about this particular decision? That's what I am going to discuss. Okay, so in simple scenario I have taken here small feature space. Okay, only having two input features and one output which we have to predict. So basically we can consider this as like this two-dimensional scenario where one axis is hours, another axis is midterm, and all these data points are basically which we already have for training our model. Okay, so for all these data point, suppose consider this particular data point. For this, total number of hours studied is this one and midterm score is this one, and we already know what is the student's final exam marks. Okay, so this is our training data set I am telling. Now let's try to understand how this splitting these values and which parameter to choose first then second, this the algorithm is deciding. So let me go to PowerPoint. So see, as I have told you, this is our actually data set. Now what it will do, first it will take all the distinct values for each features. Like here, suppose for our hours, these are only distinct values present: 5, 6, 7, 8, 11, 12, 14, 18, and midterm marks is this one: 35, 40, 42, 45, 50, 60, 65, 75, 80, 82. For all these, actually we know the final exam marks. I am again and again telling, don't confuse with test dataset. This one, this is our training dataset, known, already known. Okay, so for all this we actually know the final year final exam score. Right now we need to understand how the splitting is happening. Like here, how it is splitting, it is first deciding based on hours, total numbers of hours studied is greater than 10 or less than 10. So how it is doing, our model don't know anything, right? So how the algorithm will work? First, the algorithm will try all possible combination for all possible features. Okay, this is the first step. So suppose we are starting with hours feature. Okay, so first for 5 hours it will split like this. The whole data set is splitted like this. Okay, so one in the left hand side and another one in the right hand side. Now what it will do, it will calculate the total error due to this splitting. Okay, now how it is going to calculate, you might think. See, very simple. So here two sides are created, one is left hand side, another one is right hand side. So what it will do, in the right hand side, we know final exam marks, right? So it will take average of all the final exam marks in this right hand side, and it will calculate the squared error for individual data point with respect to that average score. Okay, this is what about right hand side. Same thing it will apply for left hand side also, and that will give us the total. If you combine both left hand side and right hand side residual, that is squared error with respect to mean score, that time it will give us total residual due to this particular splitting. Okay, because I hope you know from linear regression what is residual. That is what our actual value minus what our model is predicting, and if you square them, that is square of error is, and you take summation for all the individual data points, that time we will be getting sum of squared error, right? So similarly here in machine learning, in case of regression tree, what happens actually, suppose splitting is done, then for individual region, whatever data points are present, for all those it takes the average of the or mean of the output feature, and suppose one new test data point comes in that particular region, it will predict that average value for that test data point. Okay, so basically here the predicted value is basically average only for individual regions. So what it will do, our model each time after splitting, it will calculate the squared error in both side after splitting, or in all regions after splitting with respect to the mean score. Okay, so suppose due to application we are getting R1 as sum of squared error. Okay, I hope you are understanding what I am telling. Let me just make this bigger and clear this once more. So suppose for all these scores, if in the right hand side I am getting suppose 50. Okay, average score for all these data point, and for the left hand side actually here no data point is present, but let's assume that as 30. Okay, now suppose 2-3 data points are present here, so these data points final exam score and this score difference we will calculate, square them, this exam score and this score we will take difference and then square. Okay, so here the in this right hand side the average score is 50, so for each point, suppose for this data point the actual score is 100. Okay, so 100 minus 50, and then it will take square, like that it will combine all the errors, and suppose we are getting the error as R1. Okay, right, I hope up to this clear. Then it will not conclude that okay we will split based on hours equal to 5, greater than 5 one part, less than 5 another part. It will not take decision like that. What it will do, it will go to next possible, all possible combination. For 6 also it will calculate the same way error. Suppose we are getting R2 for 7, 8, 11, 12, 14, 18. So for all possible values of hours it is calculating the residual or sum of squared error with respect to mean. Now this is only for one feature. Now this for the all possible features also it will do the same. So now for midterm, okay, midterm equal to 35, greater than 35, less than 35, it will calculate. Suppose R9, okay, like that. For all these possible features, it will calculate the sum of squared error. Okay, it is called sum of squared error, you can say, or residual squared error, right? So now for whatever decision we are getting minimum error that it is going to take. Okay,